Let's solve Unit 4 Database Management System questions. Consider R with attributes A, B, C, D, E be relation with following dependencies. C derives F, E derives A, EC derives D, A derives B. Which of the following is a key for R? So they are asking about the candidate key, we can say. So what is actually the key? It's a set of minimal attributes with which you can distinguish a particular record. Now in order to find which particular option is going to be the key, we have to find closure with all the options. But before we start with the options, just look at the dependencies. The first dependency is C derives F. Attribute F is not a part of the relation. So we have to ignore this particular dependency for key determination. So we will ignore this. Now we have only 3 dependencies with which we have to find. Now we will start with the first option. We will take CD closure. From CD I can get C attribute, D attribute. Based on C or D individually, will I be able to derive A, B or E? No, it stops with this one. So option 1 cannot be the key. Let's take second option, EC. When you find closure, you automatically have E and C here. From E you will be able to derive A. From A you will be able to derive B. From E and C you will be able to derive D. Are we getting all the attributes A, B, C, D, E? Yes. So EC can be the key for R. Let's take the third option, AE. On finding closure. So let me once again remind you, finding closure means using the dependencies and using the attributes that is given in the option. If you are able to derive all the attributes, then that is actually finding closure. If you are able to get all the attributes, then that becomes the key for this particular relation. So now we will find for AE. From A I will be able to find B. So E is already here, but just with E I won't be able to get D or C. So this is again not a key. What about AC? So from A I will be able to get B and we will have C also, but there is no way to get D and E. Only when I get E I will be able to get D. We can say that option 4 is also wrong. So from this we will rule out 3 and 4 also. Option number 2, EC will be the right answer. That is the key for R. Next question. Consider the relation T1 with dependencies and T2 with dependencies. Which of the following is true? T1 is in 3NF, T2 is in 3NF. So they are asking whether it is in 3NF and this one is in 3NF. T1 is not in 3NF, T1 is in 2NF. So let's first understand what is 2NF and 3NF. A relation is in second normal form if every non-prime attribute is fully functionally dependent on the entire candidate key and not just part of it. A relation is in third normal form if for every non-trivial functional dependency X derives Y, either X is a super key or Y is a prime attribute. So here we have something called prime and here we have non-prime. What are prime and non-prime? Prime attribute is any attribute that is part of a candidate key. In the previous question, if we say EC is a candidate key, E is a prime attribute, C is a prime attribute. Anything other than E and C will be non-prime attribute. A non-prime attribute is an attribute that is not part of any candidate key. When you have 2 or more attributes combined in candidate key, the individual attributes of that candidate key is prime attributes. Whatever attributes are not present in the candidate key will become non-prime attribute. So here in 3NF they say either X should be a super key or Y should be a prime attribute. What about 2NF? They say every non-prime attribute should be fully functionally dependent on the entire candidate key, not just a part. If they say EC is a candidate key, it should be fully dependent on EC and not just E or just C. Okay. Now we'll just start working out. Let's take the first relation T1 with attributes A, B, C, D, E, and we have the dependencies EB derives C, D derives E, EA derives B. So three dependencies are given. The first work is we have to find the candidate key. So from this you can individually work out and check. Since this is a long problem, I have found the candidate key and I am directly presenting it here. So we can check A, B, C, D, E individually as candidate key. It will not work out. Then we will take combo of two attributes. So in that AB together will not give you. Then BC together will not give you. EC together will not give you. BE together will not give you all set of attributes. Then what about AD? Just take AD closure. From AD you will be able to find A and D. From D you will be able to find E. With E and A you will be able to find B. Then E and B can help you derive C. So all the 5 attributes can be taken if AD is the candidate key. So we are concluding AD is a candidate key. Based on this candidate key, now we are finding what are the prime attributes and non-prime attributes. So what are the prime attributes here? Any attribute that is a part of candidate key. So A is a prime attribute and D is a prime attribute. Anything other than A and D, that is B, C, E will be non-prime attributes. Let's just start with 3 and F. Let's take the first dependency. EB derives C. EB is not a super key. Just with E and B, will you be able to derive all the attributes? From E and B, you can take only C. So only 3 attributes can be taken. A and D cannot be taken. So EB is not a super key. So LHS has already failed. What about C? C is a non-prime attribute. They said either LHS should be a super key or RHS should be a prime attribute. Here LHS is not a super key and RHS is not a prime attribute, which says that this particular dependency is violating 3NF, and therefore we can say T1 is not in 3NF. So this particular part is true and this one is false. Now we will check for 2NF. For 2NF they say non-prime attribute should be fully functionally dependent on the entire candidate key. What is the candidate key here? AD is the candidate key. The non-prime attributes are E, B, C. Are they fully dependent on AD? No. E is dependent on D alone and not A, which says that they are partially dependent on the subsets of the candidate key. So if you take B, it's only A here. If you take C, no. EB derives C is actually violating both 2NF as well as 3NF. Even if you take this particular dependency here, it is violating 2NF. Based on this particular statement, they are not fully functionally dependent. We can conclude that T1 is not in 2NF, which says that option 4 is also out of the race. I hope you are clear till T1. Now we will get into T2. T2 relation has attributes A, B, C, D, and the dependencies are C derives A derives B, and A derives D. So what is the candidate key? Just we will work it out. From A closure. From A you will be able to find B. What about B? From B you can take only B. What about C? From C you will be able to derive A. From A you will be able to derive B as well as D. So here you can derive 3 attributes in the A closure part, but C cannot be taken. But C closure you can take all the 4 attributes. What about D closure? Only D can be taken. So from this, C is the candidate key of T2. So from this we can say prime attribute is C because it's a single attribute there, and non-prime attributes will be A, B and D. First we have to check for 3NF condition because the statement in second option says that T2 is in 3NF. C derives A and A derives B. What is this actually? X derives Y, Y derives Z, which means that X derives Z. This part is called as transitive dependency. C derives A and A derives B combine to form a transitive dependency C derives B. Similarly, C derives A and A derives D form another transitive dependency C derives D. What is actually third normal form? The normal form that is actually in 2NF as well as which does not have any transitive dependency will be in third normal form. But here we have transitive dependencies which states that T2 is not in 3NF, ruling out even option 2. This is also false because the non-prime attributes B and D are transitively dependent on the candidate key C. T2 is not in 3NF. So let's check for 2NF. Additionally, it is not related to this question. Since the candidate key is a single attribute, there can be no partial dependency, and so T2 is in 2NF. There is no statement regarding this one. So just for learning purpose, I have given you this particular part. As for this question, we are marking option number 3. T1 is not in 3NF as the right answer. Next question. In a relational database, which one of the following is correct? So we will see statement by statement. A relation with only 2 attributes is always in Boy's Codd normal form. In a relation with 2 attributes, say R of x comma y, any non-trivial functional dependency, when there are only 2 attributes, the dependency can either be x derives y or y derives x. This implies that the left hand side is a super key. In a 2 attribute relation, a single attribute that determines the other is always a candidate key, which makes it a super key. When we know that only 2 attributes are present and one attribute becomes the super key, automatically that relation is in BCNF. So option 1 is right. Here they are asking which one is correct, and we know the first one is correct. Now we will see what is wrong with 2, 3 and 4. If all attributes of a relation are prime attributes, then the relation is in BCNF. If all attributes are prime, it means they are all part of some candidate key. Whatever attributes are present in the candidate key are called prime attributes. This property only guarantees that the relation is in third normal form but not necessarily in Boy's Codd normal form. So when you have such a statement here, it is true for 3NF and not for BCNF. So 2 is wrong. What about third one? Every relation has at least one non-prime attribute. A relation can have only prime attributes where there are no non-prime attribute. If you take the second statement as the case, then that relation will have no non-prime attribute. Say for example, when A, B, C are all prime attribute in a relation, if that is true, then this condition is definitely false. There can be a relation with no non-prime attribute and every attribute can be prime attribute. So 3 is also wrong. What about 4? BCNF decomposition preserves functional dependencies. Actually, this decomposition does not always preserve all functional dependencies. It will guarantee lossless join, but dependency preservation may be lost. It preserves is wrong, so 4 is wrong. Next question. Consider the following 3 relations. Employee, company, owning relation. Employee has 2 attributes, employee ID, employee name. Company has company ID, company name. Own table has employee ID and company ID. Which of the following relational algebra expression return the set of employee IDs who own all the brands? It means when the company table is going to have 4 or 5 entries, say for example when they are going to have 4 entries, that becomes 4 brands. We have to find the employee who have entry with all the 4 brands in the own relation. This is what they are asking. What is this symbol actually? This is relational algebra symbol for project. What is projection? The projection operator is used to select specific columns or specific attributes from a relation. So selection is about selecting the rows and projection is about selecting specific columns. Just go through the options. We have two symbols here. One is division given in 1 and 4. Then we have Cartesian product symbol in 3 options. What is Cartesian product? This will return all possible combinations of tuples where each tuple from the first relation is paired with every tuple from the second relation. What about division? This is used to find tuples. Tuples means records in one relation that match all tuples in a specific set of second relation. You can compare it with the question. This is used to answer for all or every type of queries. For example, find the students who have taken every course, or you can just find the employee IDs who own all brands. Such kind of queries will be answered by division operation. So this is the symbol that is being given here. For relational algebra, we will take it as cross product. Now we will analyze every option. For the first statement, let's get into the expression that is inside the parenthesis. We have project EID CID from own relation, division project CID from comp relation. So what does project CID comp relation do? This will project the full set of brands. So we have something like division of brands. Project EID CID own projects the pairs of employees and brands they own. This is employees and the brand IDs that they own. What does this division do? This returns employees who own all the brands. There are going to be 4 number of brands. It will choose the employee whoever has entry for all the 4 brands. They say find tuples in one relation that match all tuples in the second relation. So whichever employee is associated with all the brands that is present in the brands table, that employee details will alone be taken. Now what about project EID of the complete class? This will give you the clean list of employee IDs who satisfy the condition. Which condition? Owning all brands. Is this query or is this expression giving you what is being asked in the question? Yes. So from this we can say option number 1 will be the right answer. Now let's see about second one. The Cartesian product or the cross product combines every employee ID in the own relation regardless of whether that employee actually owns that brand or not. So in own relation we have EID and CID. This will give you all the brands together irrespective of whether the employee is having the entry for the specific brand or not. It will just combine all the tuples from this particular relation and then this particular relation and produce a pair. I mean all possible combinations will be taken is what they say, and that is not needed by this question. So option 2 is wrong. What about option 3? Here also we are using the same query along with EID and CID. It creates a cross product between existing ownership and all brands. The resulting relation will have 3 attributes: EID, CID from own relation and CID from comp relation. Here if you have only EID and CID combo, the same result will happen with EID, CID from own table and then CID from comp table. So with 3 attributes it will create cross product. So this is also wrong. Now let's go for the fourth one. Just get into the inner query here. We have project CID CNAME from own. Actually CID CNAME belongs to comp relation and not own relation. So from this itself we can say the query is wrong here, or the expression is wrong here. The relation own contains only 2 attributes. An attribute that doesn't exist cannot be projected. So from this we can say option 4 is wrong. Next question. Consider the following statements and choose the correct answer from the options given below. Data transformation is involved in data mining process. Data transformation is a crucial step in data mining where raw data is cleaned, normalized and formatted to be suitable for analysis, which states that A is true. What about B? Online database is used in data warehouse. A data warehouse typically uses offline or batch processing and not online transactional database. Or you can take it in this way. While a data warehouse often stores data from online sources. Yes, it takes data from online sources. It is not necessarily limited to them. A data warehouse can also include data from offline sources. Online database is used in data warehouse, but it is not the only source. Only online database is used, they have not given. They have told that online database is used. Taking that into consideration, we can also say B is true. What about C? Classification is a measure of accuracy. Classification is a data mining technique used to predict categorical labels like spam, not spam based on given input data. Accuracy is a metric or measure that is used to evaluate how well a classification model performs. So classification is not a measure of accuracy, it's a data mining technique, which means C is wrong. So any option that includes C can be ruled out. From this we have answer as B, D and E. Let's check with D and E. What is D? K-means clustering algorithm is based on the concept of minimizing the within cluster variance. K-means clustering aims to group data points into clusters by minimizing the total squared distances between each data point and its assigned cluster center. So when you take a group of data points, what happens in K-means clustering is it will group data like this. So how the data points will be grouped is based on the center of the cluster. Based on that only the data points will be grouped. So they say this particular clustering algorithm is based on the concept of minimizing the within cluster variance. So this is actually true. So this within cluster variance is what they say as total squared distances between each data point and its assigned cluster center. So D is true. What about E? Pattern evaluation is a process to identify knowledge based on interestingness measure. Pattern evaluation involves assessing the discovered patterns in data mining to determine their significance and usefulness based on criteria like support and confidence. Support and confidence are a part of interestingness measures. Definitely E is also true. Support and confidence are interestingness measures. So what are the options here? We have A, B, D, E to be true. A is definitely true. I don't know why it is not included in the official answer key. The official answer key states that option number 2, B, D, E only will be the right answer. But regarding A, there is nothing wrong. In my opinion, A is also right statement. So the answer can include A, B, D, E. C is the only statement that is wrong. Next question. Consider the following statements. A schedule of n transaction is serializable if it is equivalent to some serial schedule of the same n transactions. Two schedules are said to be conflict equivalent if the order of any two conflicting operations is the same in both schedule. Now we will get into the statements. A non-serial schedule is said to be conflict serializable if it is conflict equivalent to some serial schedule. This is actually right statement only. This is just given in the DBMS reference book. But in the book they would have told a schedule S is said to be conflict serializable if it is conflict equivalent to S dash. So I have mentioned along with the notation. Now we will go for B statement. A non-serial schedule is said to be view serializable if it is view equivalent to some serial schedule. This is also true only. This any schedule refers to non-serial schedule or any schedule. Now let's go for C statement. A schedule is said to be serial if instructions of participating transactions are chronologically interleaved with each other. A serial schedule is a specific type of schedule where transactions are executed one after another. So here they say the schedule is said to be serial. Serial means it will be executed one after the other. A serial schedule means no interleaving where each transaction runs completely before the next one starts. Interleaving happens in non-serial schedules. So here they have talked about serial schedule and they say if instructions of transactions are chronologically interleaved, this will not happen in serial schedule. So C is definitely wrong. Any option that includes C can be taken out. From this we know what is the right answer now. Now let's see the D statement also. A conflict serializable schedule will be view serializable also, but vice versa may not be true. If a schedule is conflict serializable, it guarantees that it can be transformed into a serial schedule based on how transactions access and modify data items where the conflicts occur. View serializability focuses on the final visible results of the transactions to the user regardless of the order of non-conflicting operations. So, view serializability is about the final visible results. It's not about the order of the non-conflicting operation. A schedule might be view serializable even if it is not conflict serializable. A conflict serializable will definitely be view serializable, but a view serializable need not be conflict serializable. That is what they say, vice versa may not be true. This statement is also right. Option number 3, A, B, D only will be the right answer. So once it is conflict serializable, definitely the view will also be serializable. But since the view is serializable, you cannot guarantee that it is conflict serializable. They say even if it is not conflict serializable, the schedule can still be view serializable. With this, we are completing Unit 4 questions.